Hi, this is Scott from Heretical Sraffa. What I'd like to do here is I would like to continue and finish the lesson that we were looking at with respect to the unassisted labor model. Here, what I want to do is introduce the gold sector into the unassisted wild strawberries model. So we're going to have two industries, really going to be separate industries. The first is going to be the wild strawberries industry. We saw that previously. And then today, what I'd like to do is I'd like to introduce the unassisted gold industry. This, of course, relates to the PowerPoint on the rehabilitation of classical political economy in the spirit of the work inspired by Piero Sraffa. And so this speaks to the question of the unassisted gold production. Malthus had originally developed this notion in 1820 in the Principles of Political Economy. He and Ricardo subsequently had a robust exchange on the matter, and then I put the particular links on the slide in the PowerPoint. The distinction that we're going to be making here with respect to the wild strawberry industry is the following. First, a similarity, both wild strawberries and the gold sector are going to be assumed to be the product of unassisted labor, which means there is no means of production input to enter into the model itself. So the complication, the means of production, is going to be eliminated. And here we're just looking at the pure distribution of the value added equal to the value of the net product. The distinction between the two different unassisted labor sectors, the wild strawberry sector and the gold sector, is that in the wild strawberry sector, as we saw, we attach the profit factor attached to it. That's 1 plus the ratio of distributive shares E. Whereas in the gold as unassisted labor sector, we're going to assume that there is no profit factor attached to it. So the model is going to look like this. It's going to be unassisted gold production. I'm here at my home office, so the quality might not be as good, but in any event, this is the deal. Okay, so the unassisted gold production, again, we're going to have the inputs ex ante. All right, input is going to be ex ante, and the output is going to be ex post. Output is going to be equal to ex post. And so we have the ex ante inputs and the ex post output. As with the wild strawberry sector, it's going to be a net output. Okay, and so this then becomes, I'm just going to write it in terms of a transactions table, a physical transactions table between the two, the same notion of the physical transactions table here between the two. This is going to be equal to, so the gold production is going to be equal to sector G. G is going to be equal to gold. All right, and we're going to assume that gold is going to be measured in XG, units XG, and that's going to be in so many ounces. All right, again, the physical unit is going to be ounces. It's going to be denoted by the lowercase x sub g for ounces of gold. We're going to make the assumption that the labor in the gold sector is equal to 1 unit of labor. We keep that constant. Actually, throughout the analysis, I'm going to hold the labor as one quantity, 1 unit of labor. I think it makes the analysis relatively transparent. And then this is going to be the net output of the gold industry, which here is going to be equal to 1 ounce of gold. Again, the argument here is that the workers in the gold industry walk along the seashore and collect ounces of gold, right? This then becomes a relationship here. So it's going to be the physical structure of production or the physical transactions table, all right? Yeah, this is going to be number 1. All right, it's going to be Roman number 1 there. It's going to be the physical transactions table. Now we're going to move to the value. And again, there's going to be a congruency between the two. That congruency relation is going to assume to hold for the gold as unassisted labor sector. Now we're going to express it in terms of our value equations. All right, so now we look at our value equations, and our value equations are going to be the following. With our value equations, we're going to have this. All right. Now recall that we're going to be looking at the matter from the distribution in the pure wage regime of distribution, I should say. So we got our value equation is going to be here. We're going to assume that that for the unassisted labor, a gold industry, we're going to assume that the wage share is going to be equal to 1. It's not going to have a profit factor attached to it, which means then that the equation is going to be this. The wage rates in whatever numeraire times the quantity of labor in the gold sector is going to be equal to the price of gold in whatever numeraire at that pure wage regime of distribution times the net output of gold, which is going to be so many ounces of gold. Now, the point of looking at the unassisted gold sector is to, let me get out of the way. The purpose of looking at the unassisted gold sector is to introduce money. All right, so what we're going to be doing is we're going to say, all right, well, let's then let the price of gold, when gold is equal to the numeraire, equal to 1 ounce of gold per ounce of gold, and that's going to be equal to 1. Now we have the relation that we're going to be looking at here. We're going to set this equal to 1, and then we're going to solve for the wage. And the idea here is that we solve for the wage in terms of unassisted gold production, and then we plug that back into the wild strawberry sector, and from there we can solve our system. This, of course, is just heuristically developed. This is nothing is unequivocal here. You can set the wage equal to 0 and equal to 1, and then solve for the gold price, etc., and measured in terms of labor. We're going to talk about that, but the purpose here is to show the relations and illustrate the concepts that we're using. So this means plugging this in, we're going to solve the following equation, where the wage rates expressed in terms of gold at the pure regime of distribution, in terms of quantity of labor, which is going to be 1 unit of labor, is going to be equal to the price of gold, which is going to set equal to 1 by assumption, times 1 ounce of gold. All right, so I'm going to put that over here. Okay, so we're going to have this over here, so we're going to solve it. All right, we're going to put here number 3. This is going to be our solution. All right, and so our solution to this problem is going to be the following here. I'll plug this in. This is going to be the gold, the gold wage multiplied by 1 unit of labor is equal to 1 times 1 ounce, which is going to be equal to here 1 ounce of gold. We go ahead and solve for gold. We solve for the wage, so you divide both sides by the labor. Here, the wage rates in terms of gold is going to be equal to 1 ounce of gold over 1 unit of labor, or 1 ounce of gold per unit labor. Okay, this becomes our unassisted gold wage rate that we plug into the wild strawberries industry here. All right, so we put here, plug into wild strawberries. All right, and so when we plug this into wild strawberries, we get the following. Okay, so I'm going to write it here. All right, now we're going to go ahead and solve our wild strawberry sector when we plug in the quantity of the wage expressed in terms of gold. Okay, this is going to be number 4. Plug into the wild strawberry sector, which is going to be sector 1. Remember, the quantity x1 is going to be equal to the units of wild strawberries, the quarts of wild strawberries. You recall from a wild strawberry equation, it's going to be this: the price of I think I'll do it this way first. Okay, the wage rates. Okay, expressed in terms of wild strawberries. I'm sorry, the wage rate expressed in terms of gold you get from the gold sector is going to be plugged in to the wild strawberry sector here. Okay, and you multiply this by 1 plus the rate of exploitation, or the profit factor, which is the exploitation factor in the wild strawberry sector, and that's going to be equal to the price of wild strawberries in terms of gold at the various regimes of distribution times the output of the wild strawberry sector. So you'll notice that we're, by assumption, setting the wage rate equal to the gold as numeraire wage rate when we have a pure wage regime of distribution. Remember, there is no profit factor attached to the gold sector, right? Plug in the numbers. This is going to be equal to 1 ounce of gold per ounce of labor times 1 unit of labor times 1 plus the rate of exploitation or the extraction factor is equal to the price of good 1 in terms of gold at the various regimes of distribution. Now you'll note here that the price of wild strawberries in terms of gold does change when we have changes in the regimes of distribution, and you multiply that by the quantity of wild strawberries, which is going to be equal to 3. Now you just go through and solve this. Here again, you'll notice that the units of labor cancel out. Units of labor cancel out. 1 unit of gold times 1 is going to be equal to 1 unit of gold times 1 plus the extraction schedule, or 1 plus the rate of exploitation, is going to be equal to P1EG times 3x1. You divide by 3x1, and the chase to which I will cut is going to be the price of good 1 expressed in gold as the numeraire, right? It's going to be the gold price of wild strawberries is going to be equal to 1 ounce of gold over 3 units of wild strawberries, and you multiply that by 1 plus the rate of exploitation. Okay? Now you'll notice that this is exactly, this is very parallel to the labor commanded standard of value, in that we have the profit factor attached to it, and it's going to be an infinite relation, right? Because as the exploitation rate increases, so does the price of wild strawberries expressed in terms of gold. This is going to be the analog of labor commanded. All right, it's going to be, you can say here, analog of labor commanded. All right, and that makes complete sense, because what we're doing here is we're setting the wage rate not equal to 1 without units. We're setting the wage rate as constant 1 ounce of gold. All right, so this then becomes the wage rate in terms of gold is going to be equal to 1 ounce of gold per ounce of labor. Okay, that's going to be the the relationship there. And so what we can do then is that once we arrived at this, we can have our configuration of exchange. And what we're going to do here is that we're going to express the configuration of exchange in 2 different ways. The first way is going to have here where the price of gold is going to be equal to 1 ounce of gold per unit labor, and the price, and let me say it again. The gold price of wages is going to be equal to 1 ounce of gold per unit labor, and we're going to leave that as constant. And the gold price of wild strawberries is going to increase without limits. Again, it's the analog of the labor commanded. Alternatively, we can express the gold price of wild strawberries is equal to 1 ounce of gold per ounce of wild strawberries, and then we can express our gold wage rate, and it's going to be a decreasing wage rate. So the relation that we looked at in the previous lesson, when the so-called real sector in developing the configuration of exchange with wild strawberries as the numeraire and labor as the numeraire, that relation is completely reproduced within this framework, and we do this here. All right, and so this leaves us then with the configuration of exchange. All right, so now what we're going to have here is the configuration of exchange when gold is the numeraire, and we're going to consider 2 different normalizations. In the PowerPoint, it's normalization A and normalization B, where normalization A is going to be the situation where we let the gold price of wages equal to 1 ounce per unit labor, and we hold that constant, and there you have your labor commanded of the wild strawberries. Gold price of wild strawberries increases without limit. Then we're going to do normalization B, where normalization B looks at, holds the gold price of the wild strawberry constant, and there you're going to have your decrease in wage rate, right? So I'll put it here. All right, so this is going to be various normalizations, various normalizations. Actually, it's only various, it's only going to be 2. All right, normalizations when gold is the numeraire, when XG is equal to the numeraire. So these are going to be the various gold prices, all right? And so we're going to have here, I call this A, all right? And what we're going to do with A is that we're going to set the price of gold, the gold price of wages equal to 1. A. All right, gold price of wages equal to 1 ounce per unit labor, and we hold that constant. So here, the gold price of labor, or the gold wage rate, is going to be constant. All right, that's going to be the first set of values. We're going to have the gold value of wild strawberries and the gold value of wages. And then we're going to have what I call normalization B. And again, the A and the B refers back to that original PowerPoint. This is going to be when the gold price of wild strawberries is going to be equal to 1 ounce of gold per ounce of wild strawberries, and we hold that constant. All right, and so that's going to be our various numeraire. This is going our various normalizations. The numeraire is the same. I want to be very clear about that. The numeraire is going to be ounces of gold. What we do is in the one instance, we set the gold price of wages equal to 1 ounce per unit labor and hold it constant. And in the second, we set the gold price of wild strawberries equal to 1 ounce per unit wild strawberry, and we hold that constant. And then we can see the distributive relations that are associated with the price form in the gold as a product of unassisted labor model. Okay, so we're going to begin here. Okay, so we have here, this is going to be the price of the price of wild strawberries when gold is equal to the numeraire. This is going to be equal to, we solve this, is going to be equal to, this is what I just did, 1xg over 3x1, right? 1/3 ounce per unit wild strawberry, and we multiply that by 1 plus the rate of exploitation, or the extraction schedule, and then here, W0G is equal to 1 ounce per unit labor, and that's what we're holding constant. Okay? Similarly, we're going to have the other instance, where in this case, the gold price of wild strawberries is going to be held constant. We denote that by 1 unit of gold per 1 unit of, 1 unit of gold, yes, per 1 unit of wild strawberry, okay, which is going to be 1 ounce of gold per ounce of wild strawberries. And then we're going to have the wage rate, which is going to just be the reciprocal of the off-diagonal component. Here it's going to be expressed on this side because of the way in which I've solved it by arguing that the wage in gold is going to be the first set of prices that we consider. There's no magic to this. It's just the way I'm setting it. But the point is this. This is going to be the gold wage rates at the various regimes of distribution. This is going to be equal to 3 units of gold per unit of labor times 1 plus the rate of exploitation to the -1. It's going to be the denominator, okay? And you can see that since this is going to be 1 over 1 plus E, as E increases, the entire wage goes down. Of course, the lower limit to the wage rate is 0, all right? Then what we do here, okay, is we take this, okay, this relationship here, and then we're going to say, all right, that becomes our gold price. And then, again, we're just trying to formalize the model here. And so we say, all right, well, let's now multiply this by the money expression of gold. All right, and so that money expression of gold, can you see that? Yeah. The money expression of gold, that's going to be your mint price of gold. It's going to be your gold standard. It's going to be the quantity of currency units, here expressed in the dollar sign, per unit gold, right? This is going to be equal to so many dollars per unit ounce of gold. This is going to be equal to what we refer to as the mint price of gold. All right, your convertible exchange rate, right? The fixed exchange rate between gold and currency units. And then what that allows us to do is, and each of them are going to be multiplied. what I did in the PowerPoint, in the simple numeric example, is I used different values of the money expression of gold, or different values of the mint price of gold for the different selections of the constancy in the gold price, such that the money prices are going to be the same. It's just a convention, and you can refer to that to see it. But now we have our money price. The money price of good one, right? I put the dollar sign there. Of good one, when we're at the various regimes of distribution, is going to be equal to, now you're going to have 1/3 dollar per unit 1 times 1 plus E. All right, now you have it in dollars, okay? And this W0 dollar sign is going to be equal to $1 per unit labor. You have your money price, or your currency price, if you will, okay? And then so too here, this is going to be the price of gold in dollar sign. Now you're holding the price of wild strawberries, now in currency units. Now you're holding the price of wild strawberries constant. This is going to be equal to $1 per unit wild strawberry, and then the wage rate here is going to change with changes in distribution, the dollar wage rate, and this is going to be equal to $3 per unit labor times 1 plus the rate of exploitation to the -1 power. And again, the -1 power simply means that it's going to be in the denominator. This is going to be the form that Sraffa uses in his book. All right, so Sraffa uses this form here. Sraffa uses this. All right, this form. Now, it's not the, he, of course, doesn't have unassisted labor, but he'll express it in terms of standard commodity, but this will be the relation that he's going to be looking at. I'll come back and I'll talk more about that as we go, okay? So this completes the handout that I have there, okay, and it's available for everybody under the dialog box that develops the unassisted labor model in terms of the real sector and the monetary sector. It looks at the different configuration of exchange and all those relations associated therein. The next thing that I want to look at here, let me get out of your way. The next thing I want to look at here is we want to take this model to the assisted corn model. And the next lesson I'm going to look at is going to take this to the assisted corn model by taking a one commodity corn model and then applying the reduction to daily quantities of labor. Because one of the things that we can see is the analytical resonance between the unassisted labor model as I've developed it in these lessons and the way in which Sraffa treats the reduction to daily quantities of labor in production of commodities, chapter 6. And we'll come back to that in the next lesson, okay? All right, we'll see you later, guys. Peace. Bye.